Okay, so when I say the word leech, what's the first thing that pops into your head?
Oh, for most people, it's probably something pretty unpleasant.
Right. A murky pond, something from a horror movie, or maybe just a really gross fishing trip memory. We see them as these specialized parasites.
Textbook bloodsuckers.
Right.
Their entire identity is wrapped up in that one behavior.
Exactly. But what if that entire story, I mean, the whole evolutionary foundation of what a leech is, was just built on sand?
And that's really what this is about.
Yeah, so today we're going to do a deep dive into the source material you shared. It's about a single discovery, a fossil so improbable it just about defies all the odds.
A soft-bodied fossil, no less.
And it's 430 million years old. It completely shatters the history of the whole group, Paradinida.
It really is a paradigm shift. I mean, the accepted timeline, the one we've been working with for decades, places leeches much, much more recently in the past.
And this one fossil, which, get this, is the only body fossil of this entire lineage ever found. The only one. It proves they were around so much earlier. We're not just tweaking the date.
No.
We are pushing their origin back by more than 200 million years. And here's the real kicker.
Go on.
This ancient creature, it wasn't a bloodsucker at all. It was a marine hunter.
It just changes everything we thought we knew about how this kind of complex life got started. So over the next few minutes, we're going to unpack why finding any soft-bodied fossil is like, well, winning the lottery.
And what makes this one from Wisconsin so uniquely valuable?
And what the absence of one tiny, tiny anatomical feature tells us about the huge difference between a predator and a very, very specialized parasite.
It's a fantastic story.
Okay, so let's dig into that monumental shift in time. Before this, researchers were generally saying the whole leech group got its start maybe 150, 200 million years ago.
Right, around the time of the dinosaurs, flourishing alongside them.
Which already seems ancient to us, right?
Yeah.
But on the grand geological clock, that's actually, relatively modern. And now, just suddenly, boom, we have definitive proof of a leech from the Silurian period. We're talking 430 million years ago.
That 200 million year leap, it's almost impossible to wrap your head around.
To put it in perspective for you, 200 million years is the amount of time that separates us, right now, from the very first recognizable mammals.
Wow.
So this discovery suggests leeches predate most of the dominant land animals that we know today.
Which forces the obvious question, if they were around that long ago, why haven't we found any until now? I mean, we find trilobites and armored fish from that era all the time.
And that is the absolute core challenge of studying any soft-bodied animal. The fossil record is, well, it's biased. It's almost entirely made up of things that had hard parts.
Shells, bones, exoskeletons.
Exactly. Things that stick around. Leeches, like jellyfish or worms, are almost all soft tissue. When they die, they just decompose. They leave no trace.
They're gone in a few days or weeks.
Yes, statistically, the odds of a soft-bodied creature being preserved are just astronomically low. We think they make up a huge chunk of all biodiversity, but they're almost completely missing from the record.
So if they almost never survive, how on earth did this one specimen get preserved? It was found in a place called the Waukesha Biota in Wisconsin.
Right. The Waukesha Biota is what paleontologists call a lager state. It's a German term.
Meaning?
A site of exceptional preservation. These places are like a little window into the past because they somehow managed to preserve soft tissues. But even for a lager state, the conditions for this leech had to be absolutely perfect.
The source material had this great quote from Carmen Anglu, one of the paleontologists. He said it required a precise combination of circumstances. So what does that perfect storm actually look like?
Well, everything has to happen instantly. First, the creature dies and has to be buried by fine sediment, like immediately. That seals it off from scavengers and currents.
Okay.
Second, the environment has to be anoxic, no oxygen, because oxygen is the fuel for decomposition.
And the third thing?
That's the complex part. You need a very specific chemical environment, usually something rich in minerals, like pyrite, that can replace the decaying tissues atom by atom before they vanish completely. It creates a mineral cast.
So Nanglu's summary was that finding this rare animal in these perfect conditions was?
Like hitting the lottery twice.
Yes.
That single fossil is a statistical miracle that shines a light into a 200 million year evolutionary black hole.
It really makes you wonder how much of the tree of life we're just completely missing.
Yeah.
But let's shift from the when to the what. What did scientists actually see on this fossil that let them say, yes, this is a leech, and figure out what it ate?
The preservation was just good enough. It showed two key features. First, The body has that classic teardrop shape, and it's segmented, just like modern leeches.
Okay, that makes sense.
And second, and this is the crucial part, it clearly preserves a large, well-developed tail sucker, the caudal sucker.
The tail sucker, right. That's the part they use to anchor themselves while they sort of inch along. So it had the body plan, the basic tools for moving around.
Exactly. But the real key to its lifestyle, as you said,
Hmm.
is in what's missing, what's not there.
Mm-hmm.
When they looked at the front end under a microscope, they found a complete lack of any specialized forward structure. No evidence of the anterior sucker,
The front sucker.
or the complex mouth parts you see in parasitic leeches today.
So no forward sucker means no piercing mouth parts, and no piercing mouth parts
Means no blood sucking,
it's that simple.
pretty much. And if you connect that missing anatomy to the environment, the fact it was found in ancient marine rock, the conclusion becomes really clear.
It wasn't a parasite hanging around waiting for a big vertebrate.
No. It was probably a generalist hunter or what we call a fluid feeder. It was likely using that big tail sucker to hold onto rocks while hunting for other small, soft-bodied prey in the ocean. Worms, maybe some early arthropods.
Or just drinking their internal fluids without needing all that heavy-duty piercing equipment.
Precisely.
It's just incredible to me that you can figure out an entire ancient diet from one missing body part. But let's talk about that evolutionary leap. If the hunter model was the original path, how big of a jump was it to become a dedicated blood feeder? What had to change?
Oh, it's immense. The transition from a general predator that drinks fluids to an obligate blood feeder is a massive evolutionary undertaking. You're not just eating a meal, you're fighting a host's entire defense system.
Right.
Think about all the tools you need. First, you need sharp mouth parts, like the little jaws of a medicinal leech, just to break the skin. Then you need powerful anticoagulants.
Things to stop the blood from clotting.
Exactly, like hirudin. It's one of the most powerful natural blood thinners we know of. Without that, the wound would clot instantly and the leech would starve.
And it's not just about getting the blood out, is it? Actually, digesting pure blood has to be a challenge.
A huge one. The leech needs a very specialized gut, often filled with symbiotic bacteria, just to break blood down. Blood is almost all protein and iron. It lacks a lot of vitamins. You need special enzymes to store that meal for months. It's a very complex system.
As Carmen Engli put it, blood feeding takes a lot of specialized machinery.
It does. So
Yeah.
from an evolutionary standpoint, it's just much more plausible that the simple predatory fluid drinking model we see 430 million years ago was the starting point.
And the high-risk, high-reward parasitic lifestyle came hundreds of millions of years later.
Right, probably after terrestrial and freshwater vertebrates became a common and available food source.
So this one fossil gives us the blueprint, the original model of a leech, before it's specialized into its most famous or infamous form.
That's the perfect way to look at it.
Let's shift gears a little to the discovery itself, because the human story behind it is just as interesting. The source material says the specimen actually came out of a broader investigation at Ohio State University, but nobody realized what it was at first.
That happens a lot with these kinds of fossils. To the untrained eye, they can just look like a smear of carbon on a rock, an amorphous blob.
So it takes a specialist.
It takes someone with a keen eye who knows what to look for. And in this case, that was Nanglu. He specializes in these soft-bodied species, and he was looking through the collections during the early pandemic.
Yeah.
That's when this strange combination of features really caught his eye.
And he didn't just decide on his own.
No, he had to consult with the top experts, including the lead author, Danielle DeCarl at the University of Toronto. She's an expert on modern leeches.
So what was the final confirmation? The smoking gun?
It was that unique combination of features you just can't find anywhere else. The clear tail sucker, plus that very distinct pattern of body segmentation. That's a trait only found in the leech lineage. That's what sealed it.
And that confirmation lets us securely connect this 430-million-year-old animal to the leeches we see all around us today. And they are wildly diverse, aren't they? It's not just the medicinal leech in a pond.
Not at all.
Yeah.
Today's hirudinida live everywhere. Deep oceans, fresh water, even humid jungles on land. And their diets are just as varied. Many are scavengers, plenty are still predators.
And of course, a very successful group became the parasitic blood feeders we all know.
And this fossil just provides this beautiful confirmation that the predatory fluid drinking lifestyle was likely the original successful path. Parasitism was a massive specialized detour that came much, much later.
So this leads us to the big so what for you, the listener. This is about so much more than just leeches.
Absolutely.
Mhm.
Scientists studying these organisms are basically detectives trying to piece together the entire history of complex life. If we only look at the history written in shells and bones, we're getting a really distorted picture of the
A
past,
skewed timeline.
a deeply skewed timeline. If you miss the history of all the soft things, the worms, the ancestors of insects, you're led to believe that the complexity we see today is a much more recent phenomenon. This one fossil, this one improbable data point, forces scientists to rethink the timing and the speed of evolution across the entire tree of life.
It suggests that whole branches of that tree were rooted much deeper in time than we ever thought, and they just vanished from the record because they didn't have hard parts.
It's like trying to write the history of humanity using only granite monuments. You'd miss everything made of wood or fabric or paper. You'd miss most of the story.
That's a great analogy.
There's a quote in the source material from Nanglu that I think just sums it all up. He says, "We don't know nearly as much as we think we do." It's humbling. This paper is just a beautiful reminder that the tree of life has incredibly deep roots, and we're only just beginning to map them.
It's phenomenal. One fossil, one soft-bodied specimen from Wisconsin, and it completely rewrites the story. We started with this familiar image of a 200-million-year-old bloodsucker.
And we end with a 430-million-year-old marine hunter.
So if we pull back from the leech itself, here's a final thought for you to chew on, based on all this material.
If a creature this common, a leech, one we thought we had figured out, has its entire history pushed back by over 200 million years because of one single, impossibly rare fossil.
Yeah.
Imagine how much of the rest of the tree of life is still completely unmapped. How many entire lineages of animals are we missing simply because that perfect storm of rapid burial, no oxygen, and the right chemistry never happened for them?
A stunning reminder that the history books are always being revised, one spectacular, unlikely deep dive at a time. Keep digging, keep learning, and keep challenging those assumptions.